वेलकम, यू आर वॉचिंग ट्राइसिटी न्यूज टुडे चैनल और सभी दर्शकों को प्यार भरा नमस्कार।
Hello. So at Indorama Ventures Center for Clean Energy, one of the research we are doing is how to decarbonize the nighttime air conditioning in residences. So one of the major challenges that we will face in the path to decarbonization is the air conditioning consumption in homes in the night time. And at that time, the photovoltaic energy is not available. So how can we store the clean energy which is generated by photovoltaics in the daytime and use it in the night time? Concept is very simple. Just convert water into ice using chillers in the daytime and melt the ice in the night time and provide the cooling. So this facility you see here is just doing exactly the same for the hostel building that we have here. The hostel has 200 rooms and about 400 students occupy that. And we will see how we are able to decarbonize the total energy consumption in this hostel and learn out of this experiment and do further research on new materials, controls, and behavioral aspects.
Just to add to that, I think what we're already seeing is an increasing cooling demand in India across the board because of the increasing heat stress. And cooling is putting a lot more pressure on the energy systems. And whatever we are adding as a country in renewable energy is all going towards cooling. So the idea is to see how we can actually bring about innovative cooling technologies that is more sustainable and cost effective. We're quite happy to partner with Plaksha to have this facility set up out here to actually test a very innovative technology, which is a phase change material, which can be a good alternative to battery storage. So then have battery storage for renewable energy that is produced to be stored. You can actually store thermal energy using PCMs, which is cost effective and also has a much longer useful life and much lesser environmental impact compared to battery. And of course, it's cheaper as well. So I think we're quite happy to test this pilot out at Plaksha University to essentially test out a very innovative new technology and see the possibility for it to be scaled across India in a lot more residential buildings going forward.
तो जैसे आपने बताया दिन में कंज्यूम करके नाइट में हम यूज कर सकते हैं, तो इसे हम कमर्शियल में कैसे करेंगे? कमर्शियल प्रोजेक्ट्स में या फैक्ट्रीज वगैरह में इसमें कैसे करेंगे?
बिल्कुल ऐसे ही. So what happens is whether it's commercial, in this case because there is a lot of peak demand for residential, right? So we basically produce cooling in the daytime and supply that in the night through storage. For commercial, what would happen is in the night time when the demand is lesser, chilled water is produced and stored. And then
रेजिडेंशियल प्रोजेक्ट के साथ अभी तक आपका कोई टाई अप कहीं लग रहा हो?
Not in India specifically, but outside, of course, in many countries we do for residential. And
where?
Across the Middle East, in Dubai, Abu Dhabi, Bahrain, right? And
India में कब तक होगा?
in India, you already have district cooling planned in residential. For example, in Hyderabad, there is a fairly big, which Vishal can talk about, a fairly big residential complex where each apartment would have normally had about 10 tons of cooling through the window units and so on. So about 400 units were there. So had they not planned a central cooling plant, they would have had about 4,000 tons of ACs put. But because they were able to put a central plant to meet the same demand for residential from one single plant for all the apartments out there, they were able to bring about a diversity benefit of 70 to 80%. Right?
To give you this Hyderabad example, so 400 flats, each flat, if they would have gone for conventional system, that would have been 4,000 tons of air conditioning. They went for central. So instead of 4,000 tons, the load reduced to 400 tons. So 90% reduction in the air conditioning requirement, right? So that's a reduction in capex. Then OPEX also there is reduction because the charging is happening in the daytime when photovoltaic energy is much cheaper than the nighttime grid energy. So this technology can give you less OPEX, less capex, as well as 100% clean energy. So we need more, of course, more experiments, more field trials, and this setup will help us doing that. And then if it works, the whole idea is, can we have a policy which facilitates that new construction of homes have some kind of a storage system so that nighttime load because of air conditioning is avoided on the grid.